Hello everyone, and welcome to my new video on my Mathematics Essential series. In this video, I will continue proving trigonometric identities, and specifically, I will prove trigonometric identity 4 from our list of 19. Now, as I've said in previous videos, once we have proven trigonometric identities 3, 10, and 11 geometrically, the rest will follow just by application of identities already proven. So I will show you two proofs for trigonometric identity 4. 1 plus the square of the tangent of some angle theta equals the square of the secant of the same angle theta. I'll show you two proofs. One you're more likely to see in a math class, and another one is less common but much quicker. Okay, now let's start the proof. I'll go over here. In order to prove it, let's write out what we are proving. We are proving trigonometric identity 4, which is 1 plus the square of the tangent of theta equals the square of the secant of theta. Okay, now recall that secant of theta is a reciprocal trigonometric function, and in particular is equal to 1 over the cosine of theta. So the notation is kind of redundant. I mean, we don't really need that notation. It's not all that convenient to introduce that notation, but one reason to have the notation around is because it provides a way of expressing this, okay, and distinguishing it from this notation, which means the inverse function of cosine, the arcsine of the angle theta, okay? Now, before we prove this, just a word about proving trigonometric identities, okay? If you are going to prove a trigonometric identity directly, what you should do is start on one side of the equation and derive the other side. So if we start on the left-hand side, we just apply some algebraic manipulation and possibly some other identities to derive the right-hand side, okay? Now, what I'm contrasting with this with is the fact that you cannot work on both sides of the equation, because if you do, you are assuming that the equality holds, and that is precisely what you are required to prove. So doing so is circular reasoning, which is a logical fallacy. So you shouldn't work on both sides of the equation. Now, there's no hard and fast rule to determine which side you should start on, and technically, if the identity is true, then you should be able to start on either side and derive the other side. But usually, it's easier to start on the more complicated side and simplify in order to derive the more simple looking side, or the simpler looking side. And that's because it's easier to start with something complicated and simplify it than it is to start with something simple and make it more complicated. Okay, it's a little bit counterintuitive to start with something simple and then complicate it to derive some more complicated other side of the equation. Okay, so let's start the proof. Okay, so proof, we'll start on the left-hand side. 1 plus the tangent of theta squared equals what? Well, just get rid of this. So we have space. Okay, it equals, well, by definition, tan of theta is the sine of theta over the cosine of theta, but it was squared, so we could either put it in brackets and square it, or we could just square the numerator and denominator. It's the same thing. Okay, now we can rewrite the number 1 as any quantity over the same quantity. So we should choose a quantity over the same quantity that allows us to have a common denominator. So in order to do this, it would make sense to write the number 1 as the cosine of theta squared over the cosine of theta squared, because now we have a common denominator with this fraction term, the sine of theta squared over the cosine of theta squared. So now we can write this as one fraction with the cosine of theta squared plus the sine of theta squared in the numerator and the cosine of theta squared in the denominator. And now in the numerator, okay, you might recognize that expression as the Pythagorean identity. Okay, that's identity number 3, which we have already proven. This one here, which says that the sine of theta squared plus the cosine of theta squared equals 1. Well, that's what we have in the numerator. Okay, so the numerator is really just 1. So, whoops, we have 1 over the cosine of theta squared, but this is really, I'll rewrite it like this, 1 over the cosine of theta all squared. Okay, what we have in brackets there is by definition the secant of theta. Okay, so that is the secant of theta squared, which is the right-hand side of the identity we wanted to prove. So this completes the proof. Okay. And if you wanted to start on the other side of the equation, so if you wanted to start with the secant of theta squared and derive the left-hand side, all you would do is the steps that we have done in this proof, but in reverse order. So this would be the first step, this would be the second step, and so on. And then this would be your second last step, and this would be your last step. Okay? So not too difficult to start on the other side. It's just not as intuitive. All right. Now, that's how it's more commonly proved, but you might like this proof better. Okay, so alternative proof. Okay, so write the Pythagorean identity and divide through by, what should I divide through by? The cosine of theta squared by the cosine of theta squared. Okay, now if we do this, we would have the sine of theta squared plus the cosine of theta squared equals 1. Okay, we already have proven this identity. So it's okay for us to write this and work on both sides of the equation. Okay, this here just is the Pythagorean identity, which we applied to the numerator up here in this proof. Okay, so now we just divide through by the cosine of theta squared. All right. Okay, if we do this, we have the sine of theta squared over the cosine of theta squared plus the cosine of theta squared over the cosine of theta squared plus, on the right-hand side, 1 over the cosine of theta squared. Okay, now on the left-hand side, this term here simplifies to the tangent of theta squared. This term here is 1, and this term here is the secant of theta squared. So just writing out what I just said, we end up with the tangent of theta squared plus 1 is equal to the secant of theta squared. And that completes the proof. Okay. Well, now we can go back to our list of trigonometric identities and cross off trigonometric identity number 4. And now we have proven 4 identities, which means there are 15 to go. 19 on our list, 4 down. Okay, if you enjoyed this video, feel free to give it a like or a share. If you have any questions, just leave a comment. And if you would like a notification when I upload a new video, just subscribe to my channel. Until next time, bye for now.